Introduction. I will start with the introduction. So, why there's an error when we want to send the bit and how to correct the error? As I mentioned, because of attenuation, distortion, noise, and interferences, some errors will occur, and this will lead to corruption of some of the transmitted bits. Let's see the types of error. First one is single bit error. Suppose you are sending a bit sequence, maybe a character 1011001. This one is a 7-bit say ASCII code you are sending. One of the bits may get corrupted and it may become 101001. That means this corresponds to a particular character, and at the receiver, this has been transmitted and this will be received by the receiver, and obviously the received character is different from the transmitted character. Another example, suppose you are sending 8-bit simultaneous using 8 lines. Okay, using 8 lines. Okay, using 8 lines. So you're sending, and whenever you are sending 8 bits, then one of the line may be faulty. So I will choose this line will be faulty. Okay, so faulty. So this is faulty. Whenever a particular line is faulty, obviously the signal coming through this line will be in error. On the other hand, signals coming through other lines may not be in error, and as a result, this will lead to a single bit error if a particular line is faulty. This is how single bit error occurs, particularly in parallel transmission. Then, there is another type of error which is known as burst error. Burst error occurs whenever more than one bit get corrupted. Suppose you are sending a long sequence which is 1011, 00101 and so on. Then what can happen is the duration of noise is longer than the duration of one bit. So this is the duration of noise. So duration of noise is covering 4 bits. So there is a possibility that some of these bits, say this becomes 0, this becomes 1, and this remains 0. So actually it is not necessary that all the bits will get corrupted. So out of these 4 bits, the 3 bits have get corrupted, leading to this signal at the receiving end. So we have to develop technique for detecting not only single bit error but multiple errors, including burst error. So what are the techniques and how it is being done? The basic approach is use of redundancy. Redundancy. Suppose this is your message. The message may comprise several bits in sequence, and with some additional bits are used known as frame check sequence. So these are the additional bits which you may call redundancy incorporate in the message, and that is being sent, and these additional bits can be used for not only detecting error but for correction error. That is the basic mechanism for error detection and correction.
So I will continue with Hamming code. Hamming code is a technique developed by R.W. Hamming. It is use of extra parity bits to allow the identification of single error. And in this topic, we will learn to calculate the distance between two words is the number of differences between corresponding bits. Okay. All bit positions that are powers of 2 is 1, 2, 4, 8, 16 and etc. is our parity bits. Each parity bit calculates the parity for some of the bits in the code word. The position of the parity bit determines the sequence of bits that it alternately checks and skips. Okay, stop. Okay. For example, we use 1 0 0 1 1 0 1 0, which is 1 2 3 4 5 6 7 8 bits. We will use a frame with 11 columns. We just name it is 1 2 3 4 5 6 7 8 9 10 11. The redundancy bits are usually placed in position 1 2 4 and 8. So we just name it with R1, R2, R3 and R4. This thing we call it as error correcting bits. Okay. By using this, we will check one bit and skip it and check it again and repeat the process for each of the redundancy bits. So I will use R1 for example how the check and skip method is doing. So R1 is here. So it will check one by one by skipping one each another, which is mean it will check 1 3 5 7 9 and 11. So in this it will check how many ones in the frame. If ones in the frame or bits is even, so the answer is 0. While first in the frame or bits is odd, it will be 1. And this thing will repeat for all each redundancy bits. Now I will show you for calculating this thing. I will use 0 0 0 and 0 1 1. So how this thing for these two? It is doing by 0 0 0 plus 0 1 1. 0 1 is 1, 0 1 is 2. So the output is 1 1, which is 2 ones. With this shows that distance for 0 0 0 and 0 1 1 is 2. The minimum Hamming distance is equals to smallest distance between all possible pairs in a set of words. So we proceed with the formula. Formula for detection minimum distance is dmin equals to s plus 1. While for correction minimum distance is dmin equals to 2t plus 1. Plus 1 is means of the next number. For detection is next number for s, and for correction is next number for 2t. Okay.
Alright, for now I will explain about parity check. There's two condition. First is odd parity. The second one is even parity. Okay, let's say there's a bit consists of 6 bits, 1 0 1 0 1 0. Okay, for now. If we want to determine the odd parity, we must count the number, the ones, which is 1, 2, 3. 3 is odd, so basically this is correct for odd parity. Next, even parity. Same as the odd parity, got 6 number of bits. Okay, now we count the number of bits, the ones bits. 1, 2, 3. Okay, there's a 3. The number of one bit is 3, but we need even parity, so we must add another 1 bits at the end of this frame, so it will be 4. So basically this is even parity for the frame. Okay, I forgot for the first odd parity. Although the number is the number of 1 bits is 3, we must add 0 at the back of this frame. This we call bits. So the function of this parity check is to detect an odd number of error. Okay.
Two-dimensional parity check code. Okay, so for two-dimensional parity check code, this one is one of the better approach, because by using this method, the data will be more organized in the table, which actually consists of the row and the column. So basically, this is the row parity, and this is the column parity. Okay, so I'm giving example for the even parity concept. Okay, so I'm going to write it. Going to write down first. Even parity concept. Okay, so this is the original data, which is okay. To make it even, we need to calculate the ones bit. Okay, so 1, 2, 3, 4, 5. So we have 5 ones bit. To make it even parity concept, we need to add 1 at the end, because we need to make it even. So if we add the 1 at the end, so it automatically will be 6. 1, 2, 3, 4, 5, 6 definitely will be even. Okay, so continue with the second one. Same concept also. We calculate the 1. So 1, 2, 3, 4, 5. It's odd ones, so we need to add 1 at the end, so to make it even. Same goes with this. Continue with the third line. 1, 2, 3, 4. So the ones bit is actually already even, which is 4. It's even, so we don't have to put 1, because if we put 1 at the end, it's going to be odd. So to make it even, so we just need to put 0. Okay, so this is 0 because it's already even. And then the last one is 1, 2, 3. So 3 is odd number. So to make it even, then we're going to add 1 to make it even. So this is even. Okay, so for this line, for this row, we're going to apply the exclusive OR method. Okay, so we start with this one. Okay, so 1, 1 is 0, so definitely it will be 0, because 1, 1 is 0, 0, 0, 0, so it will be 0. Okay, and then this one, 1, 0 is 1, 1, 1 is 0, 0, 1 is 1. Okay, and then the third one, 0, 1 is 1, 1, 1 is 0, 0, 0 is 0. And then for this, 0, 1 is 1, 1, 1 is 0, 0, 1 is 1. Okay, and then continue with this one. 1, 1 is 0, so it will definitely be 0, because this one 0 and this one is also 0. And then this one, this line, the second line, this the third last line. Okay, so 1 0 is 1, 0 0. So definitely it will, sorry, 0 1 definitely will be 1. Okay, and this one is 1 1 is 0, 0 1 is 1, 1 1 is 0, so this one is 0, and the last one is 1 1 is 0 because Sam. Okay, so 1 1 is 0, 0 0 0, 0 1 is 1, so this is 0. Okay, so this data, this last row, okay, will be sent. So this one will be sent. Okay.
What is CRC? CRC stands for Cyclic Redundancy Code. So how does CRC work? So when a sender wants to send data to the receiver, the data must undergo generator, which is the attachment of the check code, check value attached to the code data word to form code word. The check value plus data word will form code word. So this code word then will be transmitted. So during transmission, there are possibilities that the code word is being altered by a certain issue. So the code word must be checked by a checker. So how does it check using CRC? Is that the check value will undergo the division with the data word to determine the remainder. So if the remainder is 0 0, that means the code word is correct, not altered. So if written 1, it means there's error. So if there is no error, the checker will discard the check value. So now I will teach you how to do polynomial division. So we go like this. So we have a code word 1 0 0 1 1 1 0. So we want to divide with the second 1 0 1 1. So it's supposed to return 0 if there's no error in the code word. So all we have to do is perform XOR to the code word. So we have 1 0 1 1 XOR 1 in this one. So let's start with 1 0 0 0 1 will be 1 0. So we become 1 0 1 0 1. So here we become 1 XOR 1 will be 0, 0 0 will be 0, 0 1 will be 1, 1 1 will be 0. Then we bring the sum down. What can I divide here? So because this is 0, this is 1. So 0, so we become 0, 0, 0. Okay. So 0 XOR 0 will be maintain 0, 1 XOR 1, 0, 0 will be 0, 1 0 will be 50, we become 0, 1, so this is effective step. Now it will become 1 1 0 1 so then it will become 0 Now we have another 0 here, we can't leave it here. So we bring the 0 down. The 0 would be another 0. It will be 0, 0, 0. We can add in 0 1. So stupid. So divide it by 0, 0, 0. The answer will be 0, 0, 0. So this means there's no error in the code.